Silakan di record dong.
Oke.
Saya ada kendala ini, error ini. Semua monitor.
Ya Pak.
Bantu itu dong, admin peserta ya. Saya cari videonya ini dulu, masih hang WA-nya.
Ini videonya Bapak udah ada belum?
Iya nih lagi nyari nih WA-nya hang.
Kalau nggak aku chat ke Zoom aja deh.
Ya ada di Kanurma ada tuh.
Oh,
normal play.
Itu WA-nya ada yang videonya ada yang 10 menit, ada yang 4 menit.
Yang 4 menit, yang 4 menit.
Yang di play yang 4 menit.
Iya, ya.
Aku ngomong dulu ya, Kak.
Ya, ya.
Videonya dari siapa? Dari aku?
Dari kamu ya, tolong ya. Ini WA saya masih hang.
Aku masih peserta dulu ya.
Ya, thank you.
By the way, Pak Fanky burem.
Aku masih peserta ya?
Ya boleh. Aku ngomong dulu sedikit ya, Kak, baru video. Thank you.
Silakan.
Ya. Selamat siang Bapak Ibu rekan-rekan semua, saya Amanda MC pada kegiatan kita siang ini. Mohon bersabar menunggu peserta yang lain, tetap pastikan mic Anda dalam posisi mute selama kegiatan berlangsung. Kita akan memulai 5 menit lagi. Selamat siang, Bapak, Ibu, rekan-rekan, para Digital Transformation Captain. Kita akan memulai rangkaian acara webinar kita. Terima kasih atas kehadirannya. Dalam kesempatan yang baik ini, kita akan membahas tema mengenai Water and Waste Management. Kegiatan ini didukung oleh APTIKNAS, Asosiasi Pengusaha Teknologi Informasi dan Komunikasi Nasional. Diadakan oleh Event Cerdas, One Stop Digital Transformation e-Services. Didukung juga oleh media partner diskom.web.id, portal teknologi informasi, komunikasi, dan hukum. Webinar ini akan dimoderator oleh Fanky Christian selaku Sekretari Jenderal APTIKNAS. Silakan Pak Fanky.
Oke, baik. Terima kasih Amanda. Selamat siang Bapak Ibu rekan-rekan. Selamat bergabung kembali dalam kegiatan kita di Kamis siang. Kita kembali membahas beberapa tema menarik ya di kali ini sehubungan dengan rencana kegiatan Expo besar kita di minggu depan, ya Indobultek di ISBSD Tangerang. Jadi saya kembali mengingatkan untuk teman-teman yang ada di Jakarta dan sekitarnya bisa hadir dalam kegiatan webinar kita, kegiatan Expo di tanggal 16 sampai dengan 20 di ISBSD ya. Nah, kemudian juga untuk teman-teman yang ada di Semarang ya, kami ada di tanggal 15 November. Kita kembali mengadakan seminar di Semarang di Hotel Quest. Silakan nanti teman-teman yang ada di Semarang bisa bergabung di lokasi, mendaftar dulu di link yang ada. Silakan lihat di eventcerdas.com. Ada kegiatan kita Digital Transformation for Smart Manufacturing yang akan dilaksanakan tanggal 15 siang ya. Oke, nah kenapa water dan waste management kita angkat dalam tema kita kali ini? Karena menurut kami ini jadi hal yang penting dalam beberapa tahun belakangan ini, di mana water dan waste ini menjadi kendala di banyak tempat ya, di banyak kota lah di Indonesia terutama. Pengelolaan air, pengelolaan sampah ini menjadi penting dan sejauh mana teknologi ataupun pengelolaannya itu seperti apa ya, mungkin itu yang nanti kita akan coba dengar pengalaman dari salah satu narasumber kita. Nah, mohon maaf nanti penyampaiannya mungkin dalam bahasa Inggris, meskipun Damy sebetulnya masih ada orang Indonesia ya, darah orang Indonesia ini ya. Oke, jadi saya undang aja langsung dulu Damy Heezen ya, sebentar saya tampilkan di layar. Nah, ini halo Damy ya.
Siang.
Oh, yeah, sorry ya. Yeah. So yeah, Damy will help us to more understand about the water and waste management based on his experience ya. This is interesting ya teman-teman. Jadi we will listen what the water and waste management based on the Damy Heezen experience. In detail, Damy will explain about the Sysnesia and what the Sysnesia can do. Tadi juga teman-teman sudah melihat ada video ya, ada video buku atau e-book yang nanti teman-teman bisa beli juga apabila ingin tahu lebih banyak terkait dengan apa yang Damy miliki ya, skillnya terkait dengan pengelolaan kota ya. Oke. Jadi I think I will pass to Damy. After that we'll do some Q&A session. Silakan teman-teman nanti ada pertanyaan sampaikan di chat, nanti kita akan bahas setelah presentasi dari Damy. Damy, I think the time we'll try to limit in 1 hour the webinar. Let's make it 30 to 40 minutes, yeah.
I think 30, 40 is enough, yeah.
Yeah, okay. Thank you, Damy. Go ahead.
Well, thank you all for joining here today. I will try to speak slowly. Maaf ya, belum bicara bahasa benar. It's like this. When Pak Fanky asked me waste management and water management, then normally I would come with all kinds of examples for Indonesia, but I think as solutions, but I think that is not the point. I think the point is when I'm here in Indonesia now for 6 years, and the whole water and waste management should be understood from the basics. So what I did is I took for water management an example, how one of our cities have the same challenges as all the coastal cities in the northern Java, meaning the rising sea level coming and also rivers flooding into the city. And how can you protect the city on a sustainable and profitable way. One of those cities started with that in 2006, and they're already done. So the whole city is now water resilient, how they call that. And next to that, I will explain the basic principles of waste management and mostly what I'm going to do with the topic waste management is explain what not to expect from it, because people have a certain opinion about waste management and technical solutions. When we invest, we want things to make profit, and waste management is a kind of thing that is needed, and until now, it's not actually profitable. So there's a contradiction in that. So let me start the slides. I will start with water management. I will start with a little bit of history, because in Indonesia, people have the feeling that Indonesia is the only country flooding the whole time. But I can tell you, as you can see, it's a little bit less water than here when Banjir. But also in Amsterdam and Rotterdam, in whole Netherlands, we have actually flooding every day, because water keeps changing, more water is coming. So it's a situation that keeps on going on. When it started in the Netherlands for real is in 1953. Some people will remember that. The dikes broke, and when the dike broke, the whole area of Zeeland flooded. And with that, a lot of people died. And the whole delta of the Southwest was flooded, as you can see in the map. All the rivers go out of their shores, and the water came in. There was a massive destruction. People, the housing were like that. And then was a lesson from the Netherlands. Okay, we have to do something about it. And the first thing what they did, they built a big dam. It was the Oosterschelde Dam, and that was a big dam that to prevent, to regulate the tide of the sea, so they could control the water level of all the rivers inland, right? And that's one of the solutions that they created in that time. So in the Netherlands, all the water levels are measured in the same base level. We call that normal Amsterdam peil level. At the height of the NAP is 0, and it's equal to the main sea level of the North Sea. And this is a special pole in the river in Amsterdam, and that's the symbolic number 0. And everything is measured above or below. And so until today, even when Rwanda is one of the best countries in the world in water management, we still have challenges, and it still causes problems, big problems. If you see the picture, the rivers of the Rhine, like the Rhine and the Maas, they start in the mountains in other countries, and the melting ice always comes down with all the river together, and then it will flood also the highland, and so the inland of the Netherlands. And for example, last year in Limburg, that is one of the provinces with the highest NAP level, maybe 30, 40 meters above, it was destructive. Cars, furniture, houses, everything broke down, simply because rivers flooded. Right? So it's not an Indonesian thing that flooding damages. This is just last year in the Netherlands because of the flooding rivers that come from Germany and France into the Netherlands. As you can see, how much devastation. Then, so even when we are the best, we still have big threats, and the biggest threat is still to come. Like Indonesia, the sea level is rising, and in the Netherlands, they expect a sea level rise of 5 to 7 meters, and maybe even 15 meters. And that's a huge challenge, mainly for cities like Amsterdam, who's 2 meters under NAP, Rotterdam, who's 5 meters above NAP, and The Hague, that is 6.5 meters under NAP, but also sinking like Jakarta. And that is also a big challenge. And so if we do nothing, then the Netherlands will flood like this. More than 40% will be underwater if we do nothing. of course, we did something, and that's what I'm going to explain a little bit about. Many cities are already prepared in the yeah, I don't say that in English. In the Waddenzee, there's already IJsselmeer. There's already a lot of improvement. There's a lot of canals that they are making, a lot of water irrigation, sponge systems. So there's a lot of work going on, deepening the lakes. So let's take Rotterdam as example. Rotterdam and Amsterdam, there's a lot challenge of rainwater, separately from the threatening sea level that's rising. And when the sea level rises 5 to 6 meters, this is a really big problem for the almost 800,000 people that live in Rotterdam. If you see, this is a normal rainy day. And it's the same bungee that we have, that we can see here also in Jakarta, for example, or actually in Java and other islands. So it's not rare. And we still need to manage this. And we did a lot. I will show that. So let's take Rotterdam. If they do nothing, then the city will look like this. This is actually normally a boulevard and in the business area and the tax office at around the Erasmusbrug. So how did Rotterdam solve that? Because that's actually what we want to know. How did they manage to protect the city from the sea level and the increasing rain? They're not done yet, but the targets that they had for the first protection plan and transition of the city is already done. So the last 15 years, they worked hard on it. And of course, they're not done. They're going to do it further on. There are some boundary conditions. So there's a rainwater ordinance. That means that the government have a building regulation, that there's a rainproof development where 60 to 90 millimeter per hour rain should be absorbed into the infrastructure or store or drain. And so store at least 60 to 90 liters rainwater per square meter and drain this over the next 6 hours. So meaning by water reservoirs, by lakes, by ponds, everything that is possible to absorb water, the infrastructure have to absorb that. It is also for many reasons. And the ambition is that there will be a lot of green roofs, because green roofs also hold water and then the plants use it. And that way it benefits. And if you combine that, in this case with facades, you have the same effect. And also with building water robust, meaning merging the building with the water usage. In the big plan, when you look at the big plan, first, what Rotterdam did is the side rivers of the Maas, so the rivers that access the city directly, they created the storm surge barrier, simply to protect the city from the water from the seaside, to make sure that that part is controllable. The river water is a little bit more difficult than the sea. Rotterdam made a new water development plan, not only to protect the city, but also to let water become one with the city, and part of the city will be on the water, and part of the city will be serving as a sponge to store and manage water. If you see that the central area, that's where all the shopping is and the big shops and offices, that is a single city and sponge city. Many of the water that area is actually absorbed by underwater structures and smart engineering and green rooftops. River City is, of course, living with the city, and that is now expanding in this area where they are creating floating harbors, but also floating living blocks. And then we have Canal City, and Canal City is where we smartly merge the water into small canals in the parts where we live. And that makes a triple function, right? A good example of sponge function is the Maas Boulevard. Maas Boulevard is a big boulevard, looks like a lot of concrete, but what's really happening under the Maas Boulevard is that one way they have, I see on the right, they have water canals under it. So when the river floods, the water goes under the road first instead of above the road. They have special areas that you don't see here that can flood. So that means that way the water have more space, the river can expand a little bit. And to make sure that the return on investment of the infrastructure is shorter, they created parking garages, and they created all kinds of facilities like swimming pool, like hotels, like restaurants and shops, but also apartments on the boulevard. So that way you can actually make sure that such solutions become profitable and get a lower return on investment. Because in the end, it doesn't only have to cost money, it also have to make money. That's the most important. To sponge more water, and to use the benefit, the city gives subsidy for green roof. So in Rotterdam, green roofs are booming at the moment. It started all with the picture on the right. It's a little bit weird that I put that one on the right. That is a duck park. Duck park is actually a sea dike that protects the city inside for cold air from the sea. Next to that, all these small little windows here are big shops. You have to imagine 10 meter to 12 meter high plafond, with shops like McDonald's, with shops like IKEA, with shops like yeah, big shops where you can buy all kinds of things. Inside, you can also park your car in 2 stories. And then on top of that, you have a rooftop. And on the rooftop is a park. And the park there is where people can relax, a picnic and that kind of stuff. So it is one of the most smartest objects in the world, I think, with multiple space use. And that is not only interesting because of multiple space use, but multiple space use also makes it more cheaper and profitable than any other kind of construction, and it is most sustainable. And then you see this one is eating from the roof. Here they cultivate all kinds of crops that they serve to the restaurants below them. And in Rotterdam, that is really growing. Then more function of sponge job is that we create squares. If we see this one, this is the same, actually the same location. This one is when it's empty, and this one after it rains, it changes into a pond, and that we do everywhere. Then if you see at the entrance of the parking garage here, you can see that the water is stored on the rooftop of the parking garage. In the other side, we dig a big hole, and then we put how do you call that? A small park on it, green on it, so that the water can be absorbed under the street, but doesn't bother the citizen. This is a good example of living with the water, where we let it flood when it can, and when it's not flooding, we have more area to move for the community. And this is an area of the industrial area where we simply created all kinds close to all the office buildings to make sure that we can absorb the water. Then in the second part, we're going into the floating situation. This is a new project. It's now in I think it was in, I forgot, but they're also moving this to Rijnhaven. That is where I showed it, Rijnhaven in Rotterdam, where they want to introduce floating houses, so you can live on the water. And then we have the floating farm. Floating farm is a unique concept. What they did is they have an 800 square meter farm for 2 stories high, around 40 cows on top of it, with a location outside on the shore to graze for grass, and under a factory for all kinds of products like milk, cheese, yogurt, those kind of things, and provides own energy. So this object is fully off grid, and also provides food for the city, and that makes also possibilities to grow food and raise cattle in this case to supply the city for their needs, agriculture products. Why is this unique? Is Peter van Wingen, the founder of this, he chose for cows, not because cows are cool, but because cows are the most hardest thing to do. And of course, he could have chosen lettuce or a paprika, but if you can put cows on a floating island and it works, then we can actually grow anything. So imagine that you have a whole fleet of these kind of floating farms, then you can actually bring the farms to the city and therefore lower the cost and make it more sustainable. And all these floating buildings started with the balls that you see on the right. That's the Expo Center. This was built in 2005 and now part of a study for the ADM campus. It was placed there. It's been moved since last month, I think. Very interesting. It's floating concrete. And with this floating concrete was the beginning of floating houses, but in other areas, we also work in other countries where they use the same technologies for floating seaports, floating airports. So you can also use that for big infrastructures, and it's seaworthy. Then they have public transfer. Why do you have public transfer? It's very simple. Another way to make it profitable. If you have a long river like the Maas in Rotterdam, then you can actually go from one side to the other side instead of using the bridges, and that makes it all also comfortable and fun for the children and the travelers. Splash tours, they have 3 buses like this. It's just an experiment, still an experiment, but it's an amphibious bus that can actually go through the water, and it's a smart way to shorten public transfer routes. So meanwhile, there's a research and development going on here and there, also for waste management in this case. One of our Dutch road builders created the plastic road, and the plastic road has a double function. It reuses plastic into a road infrastructure for as well cars as bicycles. And because of plastic can be shaped in everything and anything, you can actually, in this case, also let the water flow under the road instead of above the road. And that's, of course, very smart and very interesting for certain areas where the flood is really big. These are just conceptual, it's a design. But I know that from the bicycle road is already implemented in the east of the Netherlands for the first time. So, with the present climate change, water management is a very, how do you call that, hot topic. And in my network, I will try to help Indonesia to find suitable solutions for every challenge in the business-to-business structure. This is just the next. This is just one episode about water management. The reason I chose this is simply because I have a lot of designs, conceptual designs. They are made for Bangladesh. They are made for other countries like Jakarta, where we have a lot of flood solutions. But today I wanted to show how we made it for Rotterdam. Why? Because that's already proven, it's already there, and we can learn from it. And the most important thing is that every infrastructure is different, so that means also every solution is different. Indonesia has originally 2-3 months rain season, maybe sometimes 4 months rain season, and the other months there's no rain season. So there needs to be a solution that is can balance the cost and benefit. Meaning, I have several ideas for that, but I can do that in another situation, maybe, or in a private session. For example, here we have the Silibong and we have the Citarum River. Citarum River is seen as one of the top 3 biggest disasters in the world. I live in Indonesia right now for 6 years, and I've been involved with the team of the Citarum almost a year, 1.5 years, and actually it's not that bad. It's solvable. It can be solved simply, but for that you need community development. You need people to work with you, right? So water management is a situation where we all should learn from each other. Indonesia have a lot of smart people. I met a lot of them, and what I like to share with these people is the best practices that we already have. I don't want to sell any engineering or project development or that kind of stuff, but I wanted to help them to make the feasibility studies, to find the right solution for the right challenges. So shortly said, how to balance water supply by smart use of rain or flooding rivers with simple and affordable solutions. Sustainability doesn't have to cost money. Water management also should not be costing money. Yes, it costs money to build it, but it should be profitable for the social economy and for the governments where this is located. Because I have just a half hour, I want to keep it this short. I hope it was kind of interesting. But Fanky, do you want to go for question and answer, or should I go to the next topic?
Yeah, I think there only one question asking whether they can get the PPT. So I think we can go forward to the next topic.
We will gather the questions in the question and answer session. Okay, Mr. Damy.
Okay, then I continue.
Yeah.
So the next topic will also answer the question that I just saw. Waste management. Everybody knows waste, right? And it's a big problem. And believe me, not only in Indonesia, even in the Netherlands, waste management is a big problem. I'm going to show very simply how we do it there. What is how does the Dutch do the waste management? And then I will explain a little bit about the basic principles of the technologies. So the Netherlands is well known for having one of the best waste management in the world. We are actually zero waste. If we talk about municipal waste, and don't talk about construction waste, right? So this is because all our waste is collected as much as we can and processed. In the first picture, that is how they pick up the waste from a citizen. This is how the companies, in the second picture, how the companies offer their waste. Yes, we do split it in organic, non-organic, and sometimes plastic, and sometimes other materials, but I don't want to accentuate that because that's not the most important. For chemical waste, we also have special treatment, like what you see here in Indonesia, a lot of motor shops that serve and throw the oil in front of the door. If you do that in the Netherlands, then the government will close your shop in one day. And you're not allowed to have that next to a water. And then next to that, we have waste from constructions. And this is actually the four mainstreams of non-organic waste. And we all collect this, and it is supported by law and regulations. And if the waste is not processed according to the policies, we give fines to the perpetrators who do not process it correctly or break law. For example, if you have a car, in your car there's leaking oil, that happens a lot, especially with old cars, and it falls on the public road, then you get a penalty of a fine of 750 euro. And this is an example. And it doesn't matter if you did it on purpose or not, your car leaked, and that's your responsibility to service your car right in time. So when a drop of oil comes on the floor, you get a fine. A little bit exaggerated, but I understand. So traditionally in the Netherlands, what we do is we take all the waste without value to our waste facilities, and there is everything is being separated and processed. And the main function of these is to make heat and energy from the waste. And over the years, the waste processing evolved, and some kinds of waste that had no value now have more value than we create by our traditional burning energy factories, and they are processed by new resources to new resources. For example, in the old days, we didn't recycle the plastic bottles; we just simply burned them, and then they became the slugs, and the slugs go into the asphalt. That's how we made the waste profitable, right? And what we do is we burn it like a biomass. We burn it into energy, and we make the heat and the energy we use to sell. In the Netherlands, climate is cold, so instead of gas, we use rest heat from these factories. So most of the waste factories are old, and some of them have been closed over the years and to reduce the national CO2 emission. And the topic of waste burners causing CO2 is still a hot topic. Well, the experts are divided, since half of them believe waste burning is one of the most, I thought the sound was off, most sustainable waste compared to other available solutions. So waste burning is, according to a large group of experts in the Netherlands, more sustainable than any other way of processing waste. And not because of the CO2, but because of all the other problems you get when you process it differently. What you see in the movie, I do it without sound because that's so important. This is the most modern waste facility in the Netherlands. This is the HPC in Alkmaar. Actually, one of the projects I used to work as a contractor. And this one is aimed on low CO2 and a large recycle capacity. So next to the next slide, if you let me. Wastewater, the question I just had, also have several different methods which are forever evolving. Our main wastewater is collected and transported by our sewer infrastructure. That's how what we do with the grey water that goes into a separate channel in the sewer in the ground. We have our separate underground infrastructure for grey water. So that's not should not be mixed with the rivers. It does happen, by the way, especially in the smaller infrastructures, right? Before it goes back into the river, it goes to water treatment. So it goes to the sewer, then it goes to the water treatment, and then it goes back to the river or to the drinking facility. Some cases, because we also make drink water in the waste treatment. So that's what we do mainly, right? And then when we have the chemical industries, they are all obliged by law to have wastewater treatment installations, like you see in the middle picture. And there they clean the water first to make sure that it not damage nature. But also in the Netherlands, we have illegal dumping and legal dumping. So there are certain companies that are allowed to throw their chemical wastewater into the rivers in small proportions. And not always welcomed by everybody. Worse, a lot of people still fighting it, but it still happens. Because what the thing is, for example, a good example is Gen X. Gen X is a residue of chemical industry, and it can cause acute cancer if you drink it or breathe it. And the funny thing is that the Dutch government allows a company to for example, throw 5,000 kilo a year legally into the water, even in the drinking water. They don't mind. The problem of that is that also in the Netherlands, we have companies that not always stick to the rules. So when they have a permit for 5,000, then they will try to put in 10,000 because that's cheaper than processing it into the wastewater treatment. But that's a situation we have everywhere. Then we have, next to the wastewater, we have also plastic. Plastic is not processed in our country. So the Netherlands never have a plastic problem because why? We bring it all to Asia. However, since 2019, Asia started refusing the plastic waste from Western countries because it ended up in nature more often than it really was recycled. And the reason that for some people blame Asia being the biggest plastic polluter in the world, well, most of the experts know that the bigger part of this plastic is coming from Western countries, meaning all the plastic that you see in the sea, especially that are around the Gulf streams, the underwater, the ocean streams, in Japan, for example, in the Great Barrier Reef. All that plastic is not coming from Japan, not coming from Indonesia, not coming from Australia. All that plastic is coming from Europe and America and other European countries, and it goes underwater, travels thousands of kilometers and comes together there. That's why you have a lot of floating islands there. And some of the smart cartel people in the world, they know that, so they just buy the plastic because someone pays it for them to pick it up, and then they throw it somewhere in the sea, knowing that it will not be their problem anymore. And that is a big problem already for a long time, and not easy to solve because sometimes it's cheaper to pay someone to throw it in the sea than to really transport it into Asia to do something with it. So there's many things going on like that. And then, of course, we have agriculture. Netherlands is one of the biggest agriculture producers in the world. Number 2 since a long time. Smallest country in the world. Number 2 export country in the world of agricultural products. Also very special. Therefore, we have the most advanced waste treatment for organic waste. So the probably one of the most profitable markets of waste processing. And the common way to make natural gas in digesters, that is what we do. So we throw in all the manure of all the chickens and all the cow and all the other cattle into a digester, and we mix that with all the agricultural waste, and then we decompose it, and then we use that, make it into gas, and then the residue we use as usually as pupuk for the new land. Then when we go into process of that whole waste stream, we go into 5 steps of how waste should be processed, right? So first we collect it, and then when we collect it, we segregate it, then we separate it, then we do energy digestion of all the organic, and then we do biocompression of all the organic, and we have a new technology called pyrolysis from Regen, where we can actually reuse, we can break down molecules and rebuild the molecules in purity. And that way they can make diesel, they can make even new rubber, and all kinds of other stuff are possible with these methods. If you go to an example of a business model, how you can make waste to value. Waste to value is a big word, and you hear it everywhere. We want to invest in biomass, or in a digester, or we want to invest in pyrolysis, what we see before. This is a basic model on how you take solid waste, you split the recyclables from the biodegradables and the residues, and then you make it into fuel, or you make it into gas, and then the amount that you make based on your feedstock can become profitable, as you see in the bottom, the input and the output. And then another example of this could be that you collect the waste, you convert the waste, and you create worth, right? And that way you can create recyclables, and electricity, or gas, or fuel, right? And there are technologies that are possible in this. There's a reason I show this. I will explain it after this one. No, I will explain it now. There, if you look at the installations that I showed you before, that we burn energy, waste to energy, all the municipal waste, those technologies are expensive, really expensive. So that means that when the garbage trucks come to my house to pick up my waste, I have to pay tax for that every month. As a citizen, I have to pay tax, and because I own a house, I have to pay the tax so the government can pay the garbage truck to pick it up for me. The companies will pay a price maybe 5 to 10 times higher than me, because the garbage truck also have to pick up their waste, and they have more than me. And then we have the industries and the companies that, the industries that make waste, and they have to process the waste themselves or pay the government, plus they have to pay extra tax when they have a chemical product that they produce, or when they use chemical products. And next to that, the government will also put in money that is short to make sure that we can pay the operational of the factories that burn our waste to energy. And then the energy is our return on investment, our payment on installation. The return on investment of such old installations that are still running in the Netherlands have a return on investment of around, let's say, let's exaggerate, around 40 to 60 years. Meaning most of the factories that they built 30 years ago, they're not paid yet. And it also means that all that innovation that you get from other countries that they bring to Indonesia in this case, most of those are innovations that are technically proven, so they're really working, but they're not financially proven because they've never been operational. They come from the research and development teams of all those waste companies that have these long ROE installations, and they try to innovate now for the future. But it doesn't mean that these products work. First, I dare to be rude. Everyone that tells me that they have a technical solution that is profitable and have a shorter ROE than 10 years and a wholesale solution for zero waste, that doesn't exist in the whole world. I can ask all my experts at many universities from London, from Amsterdam, Rotterdam, even here in Jakarta, but also in Brazil, in Copenhagen. You can ask them all. There's no such thing. Yes, there are solutions that work. Yes, there are solutions that are possible to have a positive effect on the return on investment. But there's no solution that is attractive enough for any kind of investor. The only way to do that is combine these kind of technologies together. And that costs a lot initial investment. And nobody will put that money on the table easy. Unless, for example, a government, like here you have the Bekasi waste belt, they can give a guarantee to a company. For example, imagine that the Indonesian government go to a company like Hansenwinkel. Hansenwinkel is expert in waste to value and also in building waste facilities. Guarantee them that they can process all the waste the coming 40 years, and they will invest in the factory, and they will take the responsibility for the capacity. Only that step is not easy made. Making money and profit on waste is possible, but it has to be it's depending on. And the reason that many things are now profitable is because of the international subsidies on renewable energy, green energy. But those subsidies are not forever. I believe that I read somewhere that Indonesia have been given renewable subsidy for biomass and that kind of stuff the last 2-3 years. And they've been giving that to the people, to the builders, but nobody, Indonesia itself, never got the money yet from the international community. So that's a good example how dangerous such subsidies are. And that's why it's not profitable. Okay, the next, and if you go back to the organic system, I show you a little bit, last three be simply to show you what kind of technologies are possible and what they do. We have water treatment, we have biogas, and we have a boiler system, a furnace. And what we can do if we take biomass with the furnace is very simple. You can take any kind of agriculture waste, but also old furniture or recycled wood from buildings, and that you can burn that into energy to feed the grid. And it's actually but the furnace is always pretty expensive, and electricity is in common sold for $6 per kilowatt in the whole world. And to make this affordable and profitable, it should be around 11 to 12 cents. And there's the challenge, right? And then if you only get 6 cents, this will be a return on investment for 20, 30, maybe 40 years, depending on what kind of installation you're building and how big. And then you have agriculture, biogas installations. You can do it big, you can do it small. You simply take the manure of the animals, you put it in the digester and the organic waste, sorry. You put it in the digester, and then you can make it into electric. What you see here, you can make it into a pupuk, and you can make also fresh water from it. And in this case, you see here a torch. People burn the methane normally, but there are now methods also to make the gas, and that's the most valuable one, by the way, into 99% pure methane gas. So that is possible now with technologies. And the reason I promote my Dutch friend sell this is because he is the patent holder together with his partners from these kind of technologies. Then we have industrial biogas installations, a little bit of the same, only then focus on creating, making the food industries and their waste into gas and into energy, but also pupuk and water. And then the last one is wastewater treatment installation. When you see where you can make gray water, any kind of gray water with bacteria treatment into energy, into biogas, into pupuk, but even into fresh drinking water that you can also sell as distilled water if you break it down fully. So there's many ways to make things profitable. So my statements of this is that profitable technical solution for waste processing with an ROE less of 10 years. That doesn't exist. Not yet. I wish it was. And yes, there are exceptions. I know some of them, but these are patented and cannot be used by everyone. And then we have waste management starts with a good local policy and with education of the communities. For example, if I go to the company of my wife and my children are outside, I teach my children that they have to throw their waste into the trash can. And then I buy ice cream for all the children. And then what happens is that the whole group of children, they wrap the ice, throw it on the floor, eat the ice, throw the stick on the floor. And then my son, he ends up picking up all the plastic and the sticks and throw it in the trash can alone. But it's a part of education, and that becomes has to become a habit instead of a challenge, right? So a clean environment starts in 1 square meter around you by cleaning your area, and if everybody do that, it will be much cleaner already. And the key of a clean environment is very simple: work together. Bali last month is a good example where the whole community started cleaning the whole area. They just take plastic bags, walk to the mangroves, clean all the waste, and now it's clean. And it took them a few months after years of complaining. Well, this is it for now. Yeah, the book, I will explain a little bit more about the book later. But Fanky, it was within 30 minutes.
Yeah. Okay. I think we got some question already. Yeah. Let's see. Pak Muhammad Momon. How do you filter the waste which contain oil in water so they can get a clean water?
How you treat oil in wastewater? Well, there's many technologies for that, but I know by accident I know a cheap one with Indonesian resources.
What's that?
In Indonesia, we have a mineral called zeolite, and we have a type of zeolite called cleanup zeolite that can be found in the mountains. I know exactly where actually, and what you can actually do is when you have fresh water, so not salt water. If you have fresh water, and you mix that with the zeolite, the zeolites will absorb all the negative ions and the full oil. There's many studies in TU Wageningen, TU Delft, but also in Cambridge University, in London University, where we tested this, and the zeolites that is from the hard rock, so not the zeolite from the river clay, but hard rock like Sukabumi have a lot of that. Sukabumi actually has the best zeolite in the whole world with a 98% absorption for NaCl. And factually, when you would mix the polluted water with the zeolite, and use the zeolite as a filter, I can guarantee you that all the oil will be gone. Actually, every chemical will be gone, because the zeolite have a nanostructure that only allows water molecules to go through, and water molecules are the smallest from all. So that means that all the rest stays behind. Yeah. That's a way. And there's also a lot of chemical ways, but I prefer organic and cheap and effective. If you take zeolite from Sukabumi, for example, you take a glass of cola and you put the zeolite in the glass of cola and you stir it. After the zeolite is processed, then the cola will be transformed in clear water. And the moment when you put a corals of salt in it, it will release everything again. But that's a good example how strong the absorption is. I hope this answers the question.
Yeah. Let's see. Yeah. Wait. Which one? Okay, from Pak Yeremia, can you elaborate more in technical about the correlation between the green rooftop insulation and function to serve the water solution? Function to serve the water solution. What do you think, David?
Wait, I didn't hear the rest because I have Imam on the other side.
Oh, you can also see the chat, yeah?
Yeah. How many percent of the dirty water is that one?
No, there's more on the technical correlation between the green rooftop insulation and function to serve the water solution.
Okay. That's a very technical question, actually.
Nah, just the
Yeah.
brief one.
Yeah, it's like this, yeah. There are in the world several technologies available for different kind of purposes of cleaning water. Heavy polluted water, radiated water, and there are solutions for that. If you talk about separating the gray water and the fresh water, that's simply creating infrastructure for that, right? And so technically, there need to be study what's in the water, because then you know what we need to take it out. Like I said before, for example, with zeolite, we can take out oil or other negative ions from the water. That's because we know that's the function of the catalyst. When you, for example, do plutonium in water or another chemical like mercury, is a good one, right? You need different kind of accelerators to take it out, and that needs study. I cannot answer that right now. I can say, I can pretend you can do this and that, but then it will be optional, not factual.
Okay, let's see another one, ya, Pak Insinyur Fajar. How many percent of the dirty water to be green water or clean water can be produced to be used as safe in environment?
How many percent dirty water can be produced with your system? I don't have a technology system, but how many percent of dirty water to be gray water, clean water can be produced to use with the technology system? 100%. This is from Pak Fajar, right?
Yes.
Pak Fajar, do you know how to distill water?
Yes, normally they have sediments from dirty water. Normally it's not 100% you can produce. They have sediments.
True. But it has to be clean
approximately,
phases, right?
Approximately only 90% you can produce for clean water or the gray water. And the rest is the sediments.
Yes, and that has to be processed or stored. That's normal. Yeah, that's true. If you what I wanted to say is when you distill water, then always the little bits stay into the waste molecules that are already bound, and they're unbreakable.
Yes,
I
because in Indonesian regulation, for water and dirty water or P3, that's managed by PT Pal Jaya. That's a government corporation. So if we are the private company, like we are the building owners, we allow to maintain the dirty water from our building, but we still also join operation with government company, with PT Pal Jaya. So that's the point.
But are you talking about a building wastewater, or you're talking about industrial wastewater?
Building management.
In building management, we have that's still a question I don't understand in Indonesia, because in Indonesia we buy off chlorifying installations for the buildings so that we can use it for cleaning our hands. But a zilting installation is the same price and cost, and then you can drink it, and then you can make the loop 90% to 95%. You can close the loop.
Okay, I understand. So for these technologies, they have the maintenance, right? So this you produce for the maintenance also, you maintain your technology, or this just equipment or technology?
It depends. For this installation.
Sorry, your voice is not clear, Pak.
Suddenly my camera go off.
Yeah.
Okay. Am I back? Okay. So in the Netherlands we have water companies doing that. We have state-owned companies, all state-owned companies. They're now private, but they install the installations, and then they are responsible also for the quality of the water and for the maintenance of the whole technical installation, right? But the thing is, the difference between Indonesia and the Netherlands is that we have a water infrastructure on the ground that is public, distributed to all the buildings and all the houses, and then we tap water from that, and the water treatment companies, they are responsible to make it and keep it clean. And so we have no maintenance, nothing. We just pay. The people pay every month a bill for clean water, to have clean water. Right?
Okay.
So, and then when we have a situation that we have off-grid building that is cannot be connected to the water supply, then we use a shielding situation, and then you have a maintenance company that do that, and that's, of course, you need to change the filters every 2-3 months. Has to be measured on chemicals and bacteria every time. Has to be reported every year, inspected. So there's a lot of things to do, but then you can drink from the tap, because in Indonesia we do everything in the plastic bottle. So you have two problems, because the water in the plastic bottle is also not clean. Because everybody knows that if you put water in a plastic bottle and it's 30 degrees or warmer, then the microplastic go into the water.
Yeah.
Okay, I understand. Okay, thank you, Pak.
Thank you, Pak Fajar. Okay, the next question ya, Pak Fajar nih. Berikutnya mungkin sebentar ya, saya lihat. Pak Nana, Pak Krisnu. Okay, is there any audit, internal audit or external audit, how to use how about, is there any internal audit related to the waste processing?
Internal audit of waste, no, there are regulation and law. And yes, when you build like this in the Netherlands, not everybody can build a waste facility. You have to have a license. You have to be licensed by the government to be allowed to build that. So it's not just everybody can do that. So there's no audit for that.
Audit, yeah. Okay. Do you notice there are some also in Indonesia related to the audit in water and waste? Is there any? Do you know in Indonesia? Not yet, yeah.
I think Indonesia is still looking for that, because the thing in Indonesia is the audits that we have internationally for many things, also sustainability of buildings. We use the international ones. Only it's mahal, yeah. I mean, we have an Indonesian market, and then what I can do is that, and what I also know is how to make audits and how to certify it yourself, and how to create your own certification system based on your own regulation.
Okay, I think I try to catch up. I think that's all, yeah.
That's it.
The other question, I think not really related. You can see the question, right?
Where? I only saw the question for the one that if one, no, it's from Amanda. Now, how many dirty water from the grey water, clean water can be produced used with the technology?
I think that's already.
Well, yeah, we had it. What do you think about it, Fanky?
Yeah.
What is your opinion from what I explained, showed?
Yeah, I think we can learn. Yeah, there are some new information. Yeah, like spawns, for example.
Yeah.
How the Rotterdam built the facility on top of the water, right? Because there's a sponge, right? That's an interesting. I don't know whether is it possible or not in Jakarta, yeah, or in Indonesia.
Why not?
Why not?
Why not? You have to imagine. You have to think simple. The biggest problem of water engineers is they think complex. Civil engineers and don't know water, so most of the time they think too complex. But it can be very simple. Imagine that you have a road in Jakarta Timur that floods every time. Every time it's under flood, and you know that the reason it floods is because, for example, 50,000 cubic meter of water will cause this. So what you simply can do is you take an excavator, and then every 100 or 200 meter you build a pit of 20 meter deep, and you fill it up with rocks, and then you do every 50 meter, and then until you have 50,000 cubic meter that you can hold, and then the flood will be less or maybe gone, right? And if you can give it access to go into the groundwater, that means also that the groundwater will be moist again, and then the compaction will be less. Yeah. Because what you see in Jakarta is that in Indonesia, but Jakarta is the example, 4 or 5 months rain, the other months dry and heat. Meaning if in those times of heat, all the water vaporizes also from the soil. And then because of the weight of the city, it becomes more compact. And naturally, it should be that it's dry and it becomes a little bit compact, but then when it rain again, it like a sponge, it go up again. But because the heat is too long, it stays too compact, and then the water cannot go in anymore.
Agreed.
So the solution to make it more thing is simply dig holes. So sounds simple, but that's how simple it is. Of course, on a smart way, right? But that's why I have many friends who are Delta expert and know about this.
Yeah. I think the solution that our government, especially in Jakarta, they create the drill sumur resapan.
Yeah.
They try to make it to help the water fill in the gap. Yeah. But the problem is, I think the soil already packaged, right? Already full, right?
Exactly. Yeah, but also because most of Jakarta is already concrete, right? So
concrete,
what happens is the water comes, and then it immediately goes to the sea instead of into the soil.
Yeah.
Normally it goes into the soil and then balances with the seawater. But now it goes immediately
to the Okay. And also the challenge related to the waste management. Yeah, I think we are not all we split the waste. Yeah, we start from the home. Actually, we need to start splitting the waste. Yeah, start from the house, from the home. Yeah.
Yeah, in front of your door. Start with that.
But the problem is when you start splitting it, but when they collecting it and then they make it together again.
I know. Our president commissioner of Sysnesia, he's one of the committee members of Bekasi Waste Belt, right? And if you go there, if you look at it, it seems impossible to solve it, but it has to be solved somehow. I just saw that there's not many solutions, but for example, now in Schiphol, they made a new solution. That is a simple container size, 40 feet, and then 2 on each other, and that you can put all the waste in there, and then it becomes reusable products on the other side. So it makes the waste fully circular. Doesn't matter what you throw in. And
very expensive, right?
Exactly. and now it's successful, so others also start doing that. But for example, what is smart for Indonesia at the moment is Indonesia have the luck that 70% of your waste is organic, and 30% is non-organic. Right? So if you use I saw, for example, in Bogor, a friend of mine, she makes small biogas domes, cost, 60 juta. for the dome only. But if you think about that, if everybody would put that dome, then you have free gas, and that means that you can, with that gas, you can cook, you can even burn a lamp with it. There's many ways to use that in your advantage, right? But organic waste is not the problem in Indonesia, because the 30% is the problem.
Yeah. Okay. I think. Okay, let me export the floor ya for question ya. Silakan teman-teman, ada yang mau bertanya secara langsung kah ke Mr. Damy? Mr. Damy, silakan kalau ada boleh buka mic-nya lagi. Ada? Tidak ada ya. Okay, I think that's all. Damy will export your closing remark after the Amanda asking for the photo session. Amanda.
Okay.
Baik, Pak Fanky.
Oh wait, I saw a question from Jeremias. I forgot to answer that one.
Okay.
Damy, could you elaborate more technically about the correlation between green rooftops installations and the function to serve as water solution?
I think we already answered that.
No, not on the right way.
Oh, go ahead.
Yeah, no. I thought I was confused with the mixed up with the gray water. Now, rooftop installations is very simple. When you put a plant or vegetation on your rooftop, it do two things. It protects the building against heating up. Somehow the color green, same as the color white, reflect heat, and therefore the building heats up less. And when you have the soil where all the plants grow in, the soil is like a sponge for the water, right? So that is why the building can store more water, rainwater, so the rainwater doesn't go down on the street. I think if you take the surfaces of every rooftop in a street with green on it, it will probably reduce the rainfall down on the street maybe by 20 or 30%. And that is a very raw estimation.
Yeah. Okay. Okay. Go ahead, Amanda.
Oke, baik Pak Fanky. Bapak, Ibu, rekan-rekan sekalian, silakan aktifkan video kamera Anda, kita akan foto bersama.
Maaf,
Buka
admin, untuk kamera saya lagi error, admin, nggak bisa dihidupkan. Nggak apa-apa ya?
Oke.
Ya, nggak apa-apa.
Mohon izin ya.
Ya,
nggak apa-apa. Ya. Ayo silakan. Udah buka semua.
Oke. Saya tunggu semenit lagi ya. Oke. Oke, sepertinya yang lain sudah tidak ingin buka video ya. Aku foto ya. 1, 2, 3. Oke, sebentar. Oke, baik. Halaman yang kedua. Sebentar.
And if anyone has questions, Pak Fanky can always contact you to contact me, or you can share that.
Ya.
Oke, sudah Pak Fanky.
Yeah, okay. I think Damy, your closing remark, but also before that, you show again the contact number or the book. The book you can also introduce about the book. I think we missed the book information.
Shall I tell a little bit in 1 minute?
Yeah, sure.
In the Netherlands, we have how do you call that? How do you say that? Sustainability costs a lot of money. That's what we think. That's what we know. Solar panels, windmills, and in the Netherlands, we also understood that. And not, like in Indonesia, many of the quotas have no money. Still, Amsterdam and Rotterdam are two of the most sustainable cities for more than 15 years. Amsterdam now is ranking with number 2. In the Netherlands, we have a special design method that is from the Kementerian PUPR Belanda, And the design method is a method on how to collaborate together towards the project and how to, from policy, kebijakan untuk eksekusi. And what I did is I took that knowledge and I was allowed to copy paste that for Indonesia. And then on that road, while I was doing that, Amsterdam brought the old methods to a new higher level because instead of aiming on most sustainable within the budget, they wanted to aim on 100% sustainable for the Paris Agreement. So they wanted to create a new city before 2050 that is 100% energy neutral, climate neutral, and fully circular. And what they did was they took make a case study of the most successful project, like in the movie you saw in the beginning, and they make a case study of that. Then they hired 1,000 engineers and architects all over the world to review the whole city in every street and every element of the street. So you have to imagine that they did a study not only for sustainability of the building or the energy, but also for the tree and the roots and the worms that live under it. So, and they did that, and then they created a new design method in a catalog, reshaping the city like Lego. And that means that Amsterdam is going to change every street in the coming 20 years to achieve the goal to become the first 100% sustainable city in the world. And they published that in 2 books. And those 2 books are now going around the world. Everybody wants it. Everybody wants to learn from this. And everybody have the, how do you call that? The initiative to use this. However, I work very close with the experts who initiated this to Amsterdam. So I started preparing this 2 years ago. And I can say a little bit with pride that Indonesia is the first country in the world that have access to these books and the knowledge behind it in their own language. Penabit Andi published the books for me, and we created a training to help any project in Indonesia to become cheaper to build, more sustainable, and more profitable than any other project. Amsterdam Bukus is the same. They don't have money to make a city back in Juta. So what they did is they used our methods, and now they have on paper already the blueprints for the most sustainable city in the world, the most profitable way than any other common method. So if you want to order that books, you can go to bit.ly/Buku Amsterdam. There's more information there via videos. You can see the content videos, also the Team Amsterdam for the online kickoff that we had in July. And if you are really interested to know more, I can always come by. Maybe with Fanky we can do another session, especially only about the books about Amsterdam. I leave it up to you. Thank you.
Okay, that's all, including the closing remark, right?
Huh?
Including the closing remark.
The books are in Indonesian language. Only the hard copy is still in pre-order because we need 200 in pre-order first, and we have around 50 now. But the e-copy is directly available.
Yeah. Okay, I think that's all. Amanda, silakan di closing.
Baik, Pak Fanky. Terima kasih atas narasumber kami. Thank you for our speaker today, Mr. Damy Heezen,
Sama-sama.
Global Strategic Advisor Sysnesia, untuk sharing dan diskusinya. Thank you, Pak Fanky, sebagai moderator kami pada siang hari ini. Terima kasih atas peserta kami yang sudah hadir pada hari ini. Kita akan mengumumkan, sebelum kami mengakhiri acara, kita akan mengumumkan pemenang OVO hari ini adalah yang pertama, Pak Fajar Suryanantara. Apakah masih hadir? Oh ya, selamat Pak. Yang kedua ada M. Momon. Apakah masih ada Kak Momon? Saya cek. Pak Muhammad Momon. Selamat kepada Pak Muhammad Momon ya. Yang ketiga, Kak Yeremias. Ya, masih hadir. Selamat ya, Kak Yeremias. Selamat kepada ketiga pemenang tersebut. Terima kasih semuanya yang sudah hadir dan meluangkan waktunya pada siang hari ini untuk menghadiri acara webinar ini. Sampai jumpa di acara kami selanjutnya. Stay safe and God bless. Thank you. Stefan, Pak Fanky.
Ya, thank you. Damy, thank you ya. Semua thank you ya. Terima kasih ya.
Until the next.
Ya, oke. Thank you. Terima kasih semua. Pak Widi, thank you ya. Pak Fajar, thank you.
Thank you.